definition of a DC circuit. DC circuit is a circuit that controls the flow of electricity in one direction. DC is commonly found in many low voltage applications, especially in applications where the source of the power is the battery. In general terms, in order to create a circuit, we need the load, the batteries, the switch, and the wires. Once again, we need the battery, we need the switch, one fuse probably, the load is a light bulb, a motor, this is the load, and the wires. I have in the board a typical DC circuit. This is a typical DC circuit. That's the battery, those are the wires, this is the fuse, the switch on off, the load is a light bulb, and the return to the negative of the battery. This is a typical DC circuit. Short circuit. What is the meaning of a short circuit? If you remember in the first video, in the first picture, this is the positive side, the power coming in, and this is the return into the negative of the battery. If suddenly I connect one of these portions of the positive side directly to the negative, I produce a short to ground. If I connect any part of the positive side directly to the negative or ground, this is a short to ground. This is the definition that I have here. Short circuit is a low resistance connection established by an accident or intention between 2 points in an electric circuit. The current tends to flow through the area with low resistance, bypassing the rest of the circuit. In other words, is when you have one portion of the positive side of the circuit connected directly to ground. This is a short to ground. What happened in the AC circuit, not DC? It's exactly the same. It's when I have one portion of the hot line connected to ground. This is a short to ground. And this is one of the most common problems in marine installations. And now we are going to talk about the different type of circuits that we found in any electrical installation. We have series circuits, parallel circuits, and combined circuits. It's circuits that are configured in series and parallel together. We are going to study right now in details series circuits, parallel circuits, and combination of both of them series parallel. Okay, we are going to start with a series circuit. Okay, this is a typical series circuit. We are going to refresh the picture. This is the battery. I have the positive terminal here, the fuse, the breaker on off or switch on off. After that, two loads. One load and the other one connected in series. Follow me. This is the positive. The positive enter in the bottom of the light bulb, and from the case of the light bulb, start and connected into the positive of the next one, and after that, from the negative, return into the negative of the battery. Alright, this is the series connection. What happened in a series connection? What happened with the ohm load? What happened with the voltage? What happened with the intensity? And what happened with the resistance? Okay, let me check. The voltage in a series circuit increase. The total voltage will be the voltage number 1, the voltage in the load number 1, plus the voltage in the load number 3, plus the voltage in the load number 3 and 4 and 5. Yeah, the voltage increase. The total voltage will be the voltage number 1 plus voltage number 2 plus voltage number 3 and increase depending on the amount of loads that you have in the series circuit. What about the intensity? You remember when you connect two batteries in series, what is constant? The intensity. You remember when you connect two batteries in parallel, what is constant? The voltage. It's exactly the same. In this circuit, series circuit, what is constant? The intensity. The intensity, the total intensity will be equal to intensity number 1, intensity 2, intensity 3, equal to all the intensities. Oh, wonderful. Okay, we are going to solve it right now. One typical example of a series circuit. I prepared for yours this example. Suppose that we have a series circuit with 3 loads, 3 resistors. Resistor number 1, 5 ohms. resistor number 2, 10 ohms, resistor number 3, 15 ohms. And we are going to calculate all the values. We are going to calculate voltage, intensity, and resistance in each point, in point number 1, point number 2, point number 3, and we are going to calculate the three values, voltage, intensity, and resistance, and the source of the power. Total voltage, total intensity, and total resistance. Okay, in this particular case, I know the total voltage and the total resistor 1, resistor 2, and resistor 3. I need know one intensity, because the first step is identify what is constant. In this particular case, because it's series, the intensity is constant. I need know the intensity in one point, and immediately I know the rest of the intensities. Okay, what intensity will be easy to find it? Probably the total intensity. But the only way to calculate the total intensity is if I know the total resistance. But I can calculate the total resistance. How much is the total resistance in a series circuit? Is equal to resistor number 1 plus 2 plus 3. Okay, the total resistance is equal to resistor number 1 plus 2 plus 3. 5 plus 10 plus 15. Okay, the total resistance is 30 ohms. Okay, if I know, this is the next step. If I know that the total resistance is 30 ohms and I know the total voltage 20. Okay, the total intensity is 20 divided by 30 is 2/3. And right now I know the rest of the intensity, 2/3, 2/3, and 2/3. Okay, this is a parallel circuit. What is the advantage of a parallel circuit? The parallel circuit is a circuit in which the resistors are arranged with the heads together and the tails together. What is the meaning of that? You remember when you connect batteries in parallel? Positive with positive and negative with negative. Three batteries. Positive with positive with positive and negative with negative. Okay, they are in parallel. And you remember when you connect batteries in parallel, what element increase? The intensity, the amps increase in parallel. And what is constant? Is constant the voltage. Okay, it's exactly the same right now in the circuits. I have a circuit in parallel. I create that circuit for use, exactly the same. The input information is exactly the same like the previous one, 20 volts on the battery, and I have three resistors, 5 ohms, 10 ohms, and 15 ohms. Okay? Remember, in a parallel circuit, is constant the voltage. Is constant the voltage. What happened in this particular case? I know the total voltage, 20. Let me check the table. I know the total. Because I know the total, I know voltage 1, voltage 2, and voltage 3 because all of them are the same, 20 volts. Okay, right now that circuit is too easy because I know the voltage and I know the value of the resistors. If I know the resistance and the voltage, I can find the intensity in each point. Okay, let me explain the procedure how I solved the quiz. Because the circuit is in parallel, all the voltages are equals. Total voltage is 20, is equal to 1, 2, and 3 equal to 20. Alright, that's the first one. And the total resistance, you can calculate the total resistance easily because you can use the formula. 1 divided by the total resistance is equal to 1 divided plus 5 plus 1 divided by 10 plus 1 divided by 15, the values of the resistance. Okay, now the less common denominator is 30. 30 into 5 is 6, 30 into 10 is 3, 30 into 15 is 2, 6 plus 3 plus 2 is 11, 11 divided by 30 is equal to 1 divided by RT. RT is 30 divided by 11, is 2.72. What is the meaning of that? The total resistance is 2.72. Right now, I know the total voltage, I know the total resistance, I can find the total intensity. The total intensity will be the total voltage divided by 2.7. This is a typical combined circuit with this circuit in series with a parallel. The first resistor is in series with the resistor number 2 and resistor number 3. This is the diagram and this is the schematic. You have the battery, resistor number 1, in parallel with those two resistors. Okay, I did these examples and we are going to solve that example. using the same values that I used in the previous circuit. Okay, I have a circuit with the total voltage 20 and resistor number 1 5, resistor number 2 10 and 15. And we are going to find the rest of the values. This is series and parallel. Yes, because this one is in series with this and this is a parallel. In other words, I can convert this circuit in other circuit that is full series, like this. I can convert this one into this one. The first one, resistor number 1, right now, is in series with this one, the blue one, RF. But RF is the solution of this small parallel. What is the meaning of that? 1 divided by RF will be equal to 1 divided by 10 plus 1 divided by 15, because this resistor RF is the solution of this small parallel. Is clear, my friends? What is the secret when you solve circuits? Is do the table, put on the table the input information, and try, if you have a series parallel circuit, try to convert that series parallel into a series circuit. And after that, you continue step by step. This is a series circuit. This is a series circuit. This is the switch, and I have 2 light bulbs. Okay, when I close the switch, immediately the lights are on. What happens if one of the lights is broken? What happens if one of the lights is broken? Here. Okay, right now the system is out. I don't have any lights. This is the inconvenience. What happened in a parallel circuit? What happened in a parallel circuit? Like this. I have a parallel circuit with 3 lights. Okay, when I close the switch, when I close the contact, all the lights are broken. What happened in a parallel circuit like this if, for example, the light bulb in the middle, the bilge pump in the middle is broken? Let me check. In this moment it's running. I am going to the second light, the middle one, is broken, but the current passed for this and this path and close again. If I have a parallel circuit, if one of the elements is broken, the current continues for the other path. This is better. In that case, a good recommendation is install those bilge pumps in parallel, not in series.